The area surrounding the North Pole may seem like a frozen and desolate environment where nothing ever changes, but it is actually a complex and finely balanced natural system, and its extreme location makes it vulnerable to feedback processes that can magnify even tiny changes in the atmosphere. In fact, scientists often describe the Arctic as the canary in the coal mine when it comes to predicting the impact of climate change. One major type of climate feedback involves reflectivity. White surfaces like snow and ice are very effective at reflecting the sun's energy back into space, while darker land and water surfaces absorb much more incoming sunlight. When the Arctic warms just a little, some of the snow and ice melts, exposing the ground and ocean underneath. The increased heat absorbed by these surfaces causes even more melting, and so on. And although the current situation in the Arctic follows the warming pattern, the opposite is also possible. A small drop in temperatures would cause more freezing, increasing the amount of reflective snow and ice. This would result in less sunlight being absorbed and lead to a cycle of cooling, as in previous ice ages. Arctic sea ice is also responsible for another feedback mechanism through insulation. By forming a layer on the ocean surface, the ice acts as a buffer between the frigid Arctic air and the relatively warmer water underneath. But when it thins, breaks, or melts in any spot, heat escapes from the ocean, warming the atmosphere and causing more ice to melt in turn. Both of these are examples of positive feedback loops, not because they do something good, but because the initial change is amplified in the same direction. A negative feedback loop, on the other hand, is when the initial change leads to effects that work in the opposite direction. Melting ice also causes a type of negative feedback by releasing moisture into the atmosphere. This increases the amount and thickness of clouds present, which can cool the atmosphere by blocking more sunlight. But this negative feedback loop is short-lived due to the brief Arctic summers. For the rest of the year, when sunlight is scarce, the increased moisture and clouds actually warm the surface by trapping the Earth's heat, turning the feedback loop positive for all but a couple of months. While negative feedback loops encourage stability by pushing a system towards equilibrium, positive feedback loops destabilize it by enabling larger and larger deviations. And the recently increased impact of positive feedbacks may have consequences far beyond the Arctic. On a warming planet, these feedbacks ensure that the North Pole warms at a faster rate than the equator. The reduced temperature differences between the two regions may lead to slower jet stream winds and less linear atmospheric circulation in the middle latitudes, where most of the world's population lives. Many scientists are concerned that shifts in weather patterns will last longer and be more extreme, with short-term fluctuations becoming persistent cold snaps, heat waves, droughts, and floods. So the Arctic's sensitivity doesn't just serve as an early warning alarm for climate change for the rest of the planet. Its feedback loops can affect us in much more direct and immediate ways. As climate scientists often warn, what happens in the Arctic doesn't always stay in the Arctic.